Happy New Year, everyone. Welcome to today's video. And for this particular video, we'll be dealing with a probability. And I will be doing some more practice questions following a previous probability video. And for this particular session or video, we'll be looking at questions with integration to other topics in the GMAT focus edition of the GMAT exam. And so without much further ado, let's jump into today's video. Okay, we have a first practice question of the day. You can go ahead, pause the video, give it a try, and then we'll jump in and do the question together. So we have S equals to 1, 2, and 3. That's a set. And T equals to 4, 5, 6, and 7. What is the probability that X chosen from S and Y chosen from T will result in X times Y being even? So we have S being 1, 2, 3, and T being 4, 5, 6, 7. We have one even number in S and two even numbers in T. And how do we get even? Any number times an even number is even. So we have odd times even should give you even. And even times even equals even 2. What's the probability that X chosen from S? Now, we have to choose X from S and Y from T and have XY being even. How can you get this? We can get S being even and T odd. One value of S, that X being even, then Y odd. Or the other way around, we'll have X equals to odd and Y equals to even, or even when they are both. So X being even and Y being even. So for X being even and Y being odd, what's the probability that X chosen from S and Y chosen from T will result to even? X, what's the probability or the composition of X? We have to have X, which is 2, the only even number in S. So X can only take 2. That's 1 out of 3 options. And Y being odd, that's 5 and 7. Those are 2 options out of 4. That's a half. Right? Then we have X being odd and Y being even. So you can have this option or another option where X equals to odd. X being odd, that's 2 out of 3 options. And Y being even, have 2 also options out of 4, that's a half. Or the last option where you have X being even, that's only 1 out of 3. And Y also being even, that's also a half. So N means multiply or means addition. So we have a third times a half is 1 over 6 plus 2 over 3 times 1 over, that's a half. That's 2 out of 6. And lastly, a third times a half, that's also 1 over 6. If you add all this, we'll have 2, 3, and 4. That's 4 out of 6, which is 2 over 3. And that is answer choice B. Okay, let's get to a DS question. I hope it's a bit tougher for you guys, so let's do it. We have the answer choices being 12, 10. That's for A, B, C, D, and E. For those who will require it, A meaning the first statement is sufficient, the second one is not sufficient. B is when statement 1 is not sufficient, but 2 is sufficient. C, you have to combine these 2 statements to make them sufficient. And D, each statement independently is sufficient, while E, even when combined, statements 1 and 2 are not sufficient. Okay, you can pause the video, give it a try, then we'll jump in. Okay, so we have the probability that event E occurs is 0.8. Probability of E equals to 0.8. And the probability that F occurs is 0.6. What is the probability that event E occurs but not event F? That means we want probability of E and probability, not F. That means probability F not happening. Right. So let's jump into the first statement. What you already know is that given a discussion, you asked about the probability. So we need one unique value for this probability, that means this question is a value question. So we need just one unique value for this question or the question prompt so that you can prove sufficiency. From statement 1, we have events E or event E and F are independent. That means for you to find probability of E or F, you have a probability of E plus probability of F minus probability of E times probability of F, since they are independent. Okay, so we know that probability of E is 0.8, probability of F is 0.6. So what we need to find is probability that E occurs but not F. So in this case, instead of probability of E and F, we asked about probability of E and not F. In this case, the question asks about probability of E times probability of not F. That's not probability of F, but rather, let's delete this. This is times 1 minus probability of F. Okay, that's probability that F does not occur. In this case, then we have already have probability of E, which is 0.8. And you already have a probability of F, that's 0.6. So probability of F not happening, that will be 1 minus 0.6, which is 0.4. So 0.8 times 0.4, which will give you 0.32. You don't have to calculate this, as long as you already know that you can have this channel to finding the 0.32 without finding the 0.32, then you have already proved sufficiency. If you had other instances where you don't know if the types of these events A and F, if they are independent or dependent or they joint, you don't know all about that, then you already know that you don't have a path to finding this event E happening but not F. So in this case, you already have a path. You don't have to calculate this. You already know that you can find the probability of E occurs but not F. Then statement 1 is sufficient. Since it's sufficient, then S can stand, B cannot stand, since it states that 1 is not sufficient. Then you don't have to combine the statements. You've already found that statement 1 is sufficient, so C is out and E is also out. So you have to prove if it's A or D in this case now. For statement 2, this is 1. 2, we know that the probability that neither event E nor event F occurs is 0.8. That means 1 minus probability of E times 1 minus probability of F equals to 0.08, which you already know that 0.8, 1 minus 0.8, that's 0.2. 1 minus 0.6, that's 0.4, and that already gives you 0.08. This proves this is the first statement, which tells us these two statements are also independent. And thus, with that, we can say confidently that these two statements being independent, they should also be sufficient. And therefore, 1 is sufficient, 2 is sufficient, A is out, and we have D as our answer. I hope you got that question right.
You're watching Success with Bob Mwiti Show, presented to you by Upstake America. Upstake America is a consulting company that helps immigrants find amazing higher education and job opportunities in the tech industry in the United States. You can find our programs by going to www.upstakeamerica.com. Upstake America, we wake you up to the unlimited potential.
Let's have a next question where you can look at it a bit more harder compared to the previous question. So pause the video, give it a try, then we can do this question together. So we have a bag contains only red, blue, and green chips. One chip is drawn at random from the bag and put back. Then again, one chip is drawn at random from the bag and put back. What does that mean? If you have this instance where you put the chip that you've drawn back, then that is with replacement. So this is not a conditional probability now. We're dealing with replacement, giving it a not conditional, but independent bit of it. Since the probabilities don't change, don't have without replacement, instead it's with replacement, right? So the probability that both chips are red or both chips are blue is 5 of 16. One interesting thing about this is that if you have, for instance, out of this question, we have 5 blue balls and 5 green balls. And you say, you take a blue ball, we have option, we have blue, then green. And another, we have a blue and green after choosing blue, and a blue and a green when after choosing a green ball. So in this case, we have a half out of a half for the first option. If it is with replacement, then the probability of picking a blue again is a half. And the probability of picking green again is a half. As you can see, if you are to pick 2 blue balls, then it will be a half squared, right? If it's 2 green balls, then you have a half squared. In this case, if you're dealing with replacement, then you'll find yourself dealing with perfect squares when you're picking colors, balls of the same color, or balls that have the same proportion as the other. So the probability that you pick both chips are red and both chips are blue is 5 over 16. So we have both blue or probability of both red equals to 5 over 16. So or means add, remember that. So you're dealing with 2 perfect squares, we add them. Then the probability that the first chip is red and the second chip is not red is a quarter. So we have probability of the first chip being red and the second one can be blue. Or say the first chip is red and the second one is not red. The proportion of the rest. This is a quarter. So let's look at this first statement here. Okay, let's look at the first one. The question, if one chip is drawn from the bag at random, what is the probability that you draw a blue chip? Now, if you have probability of picking 2 blue chips or 2 red chips, then you have 5 over 16. So we can say either we have a quarter plus 4 out of 16, not a quarter, but 1 over 16 out of plus 4 over 16, or the other way around, 4 over 16 plus 1 over 16. Since you already know that this will be a perfect square and this will be a perfect square. The only way you can have that is 1 and 4, since you can't have 2 and 3 or 3 and 2. See, it's already 1 or 4 or 4 or 1. So if the probability of blue and blue equals to 1 over 16, then probability of blue will be a quarter. If probability of blue and a blue is 4 over 16, then a probability of blue is 2 out of 4, which is a half, right? So if the probability of picking a blue is a half, and a probability of picking a blue, okay, you have a probability of picking a blue is a half when you have the probability of picking 2 blue chips is 4 over 16, and a quarter when you have probability of picking 2 blue chips is a quarter, 1 over 16 rather. So the probability of picking red and a red can be either also a quarter or a half. If red was a quarter or a half, if you pick a red, a half, then another value which is not red, and say a half, then that will give you a quarter clearly. But if probability of red was a quarter, that means the probability of not picking a red should be 1, so that you can have a quarter. And that is not realistic. You can say the probability of not picking a red is 1 already, since you have to pick out of this total. The total is 1 actually. So probability of picking a red can't be a quarter. Instead, it will be a half. So if probability of picking a red is a half, then the probability of picking a blue should be a quarter, which is C. So here's another question. Give it a try and then I'll jump in. So we have a 5-meter long wire that is cut into two pieces. If the longer piece is then used to form a perimeter of a square, we have a 5-meter and then we have a square in this case. Okay, we need one of these long bit is cut to form a square, right? What is the probability that the area of this square will be more than 1 if the original wire was cut at an arbitrary point? So for the area to be more than 1, then you need a perimeter. Area of 1 means that this point and this point will be 1. One length will be 1, so that all sides should be 1 also. And that gives a perimeter should be also greater than 4, since you already have 1, 1, 1 for each and every side. So area being 1 should mean that the perimeter should be also greater than 4. Okay, so what's the probability that the area of the square will be more than 1 if the original wire was cut at an arbitrary point? Okay, perfect. Now, let's look at this 5-meter long wire that is cut into two pieces. And the longer piece is used now to form the perimeter of the square. So if you have a point, this long line, let me delete it and have a much more compact line. So we have the midpoint being 2.5. Let's have in sections of in intervals of 0.1. So you can have from 0 all the way to, that's 0.1 all the way to 2.5, then 2.6 all the way to 2.6 all the way to 5. So it should be longer. That means it takes a point from 2.6 all the way to 5. How many points are these? These are about 25 places or cuts that can be points of cut that can be cut. So we have 25 ways from 2.6 all the way to 5. So what do I mean by that? We have 2.7, 2.8, 2.9, all the way 3, all the way to 5. So we have 25 ways or 25 places that this wire can be cut and have a longer bit. Okay. Then at what places do we have to cut so that we have a perimeter of greater than 4, which also means the area of greater than 1. That means that on this wire, at the midpoint 2.5, we need to cut from some value greater than 4, which is from 4.1 all the way to 5. How many options are there? We have 10 options, 10 ways. These are places where if they are cut, then the area will be more than 1 or the perimeter will be greater than 4. So what is the probability that the area of the square will be more than 1 if the original wire was cut at an arbitrary point? If you have options from 2.6 all the way to 5 being the points where the line can be cut, so you can have a longer piece, and 4.1 all the way to 5 being points where if you cut at that point, then the area will be greater than 1 or the perimeter greater than 4. So in this case, they just have to get the proportion or the ratio information. We have out of these 25 ways or these 25 points, 10 points will give you an area greater than 1 or a perimeter greater than 4. That's 10 out of 25, and that will give you by 5, 2, by 5, 5, which is 2 over 5. Answer choice A. Right, you can go ahead and try different ways. You can go with steps of 0.01 and see also if we can get 2 over 5 as the answer. So in this case, we have A as the answer. I hope we got that question right. Today's video, we have some geometry here and there for those who are doing classic GMAT. We have a lot of number theory that we've done as well. We have some combinations in other areas in the GMAT curriculum or the GMAT Focus Edition. And here at the Kenya Leaf program, we offer these trainings in each and every section in the GMAT Focus Edition curriculum and the GMAT Classic Edition curriculum. So I've been Clifford Mwenda, a GMAT trainer at the Kenya Leaf program. I hope you've enjoyed the video. Please leave a like and subscribe in the channel. If you have any questions, please leave them in the comment section. If you have any inquiries, can do as well. If you have any comments, go ahead and do that in the comment section. Bye-bye.